Hi everyone, my name is Darko and I'll talk about evergreen development today. So first off, let's start with the modern web development. So how does this look currently? So when you start developing, you'll probably first create an empty folder, first spend like half an hour on naming the projects, etc. Then you'll do git init, so version control is very important. Then you'll do npm init, so you'll probably want to use some node modules. Then you'll install the whole web, set up Gulp, Webpack, SASS, Bubble, and everything. Then, I don't know, and profit. So you'll start developing about 3 hours later. So why are we doing this? So apps are getting much more complicated because, well, we want more complicated apps, and the browser APIs are more advanced, so we have more ideas how to use them. So since the code is getting more complicated, we are mostly using some frameworks to manage the complexity. And by that, with that, our code is getting bigger and harder to serve the clients and etc. So what's the problem with that? So first off, we need a build process. So we will use some task runner or something like that, but that's slow. So every time you change something, something in the background needs to process it and something needs to happen. And it's hard to debug. So here's an example of a stack trace. This example is using some more advanced features of JavaScript, but they are made to work in all browsers. So if you look at this row here and this one here, that's actually the same function. Everything in between is doing something. We'll come to this later. So that's kind of a problem. The second problem is it's hard to debug because you're not debugging your own code that you wrote. You're debugging something that someone generated. So once again, here's an example of a function. It's actually the same function. And here it's 40 lines of code. But when I wrote the function, it's actually 15 lines of code. But it's hard to see this here. So how did we get here? So let's start with 2007 and ES4. So how many of you heard about ES4? Okay, few hands, nice. So for everyone that doesn't know about ES4, these were the main features. So modules, classes, generators, and strong typing. So many of you might think, well, what's happened to it? Because, well, we got modules and classes and generators right now last year, and we still don't have strong typing, at least not in pure JavaScript. So what happened was the community wasn't ready. So there were a lot of features, and it was hard for the standard body to present it to community, and they weren't ready for it. So what they did, they separated it into a separate standard called Harmony, and instead of it, they made ES5, which is much smaller, but it has some important changes that make development easier. So that happened in 2009, so ES5. But at that point, the web apps were pretty simple yet. So, for instance, Gmail still had invites. Google Maps looked like this. And Google Docs was pretty much the most complex app that ran in the browser. And everything worked fine. But the app, as I mentioned, the apps got more and more complicated. So in 2010, CoffeeScript was published. And why? Because, well, the pure JavaScript wasn't ready yet for the growth of the web. So this was kind of an adoption. But in 2012, HTML5 was published, and we got a lot of new APIs like audio, video, geolocation, etc. And there was a lot of new opportunities for new, more complex apps. And finally, finally, last year, we got ES 2015, aka ES5. This version is pretty huge, so it more than doubles the size of the specification. So it's kind of overwhelming for new developers. And, well, it's obvious why. What it has a lot of features. So those three are from ES4 that didn't succeed, but they managed to do it in ES6. It has proxies, spread, rest, arrow functions, and etc. So we probably want to use all the functions, right? But well, it's not that simple. So because we need to transpile all the functions. So what's transpiling? So transpiling is defined as source-to-source compilation. So you have one source code and you're compiling it to another source code that you are running. And in this case, we are compiling the JavaScript of tomorrow into the JavaScript of today, so we can run it everywhere. Worth mentioning here are also source maps. They allow us to map our source code to the transpiled source code, so it's easier to develop. And it works for JavaScript and CSS. So since I mentioned transpiling, there are a few options. First one is tracer compiler. It was the first wide-known transpiler. It's made by Google, but it wasn't used that much because about 2 years ago, ES 6.5 was published. So if you're using some transpilers, you might think, well, this logo is kind of familiar. Well, because they thought, well, ES6 is 1 year and there are ES7, ES8, etc. So this wasn't scalable. So in order to stay relevant, they actually were renamed to Bubble, which suits them much better. So now we can use all the features, right? Well, again, not exactly, because not everything can be transpiled. For example, proxies and tail call optimizations can be transpiled. And some features like symbols can be transpiled, but not entirely, and with performance issues. But how does ES 2015 look in the example? Well, here's one of our examples. It's early 2015. It was our first ES 2015 project in Infinum. So the project was Backbone, Require.js, Browserify, Grant, and 6.5 back then. And it was kind of a big project for JavaScript, so it has 96 Backbone views, 45 collections, etc. The business logic is not that complex because it's mostly data visualization, but it's still a lot of code. So what were the main issues here? Well, for the empty project, without any of our code, it took 10 seconds to build it. That's pretty long. And the finished project took about 2 or 3 minutes to build. And if you change something and need to wait 3 minutes, well, that's horrible development experience. What we did, we added some caching, but we had to do it manually, and we got to 10 or 15 seconds for every change. And again, it's much better, but it's still pretty bad. And, well, stack traces were horrible, much worse than the screenshot I showed you before. And at one point, we actually had to turn source maps off because, well, they were kind of new still, and they got so big that the browsers couldn't handle them. So once the page was loaded, we still had to wait about half a minute so the source maps would load and show anything useful. That's pretty bad. But in the end, well, it looks like a big hassle, but I think it was still worth it because there was a lot less code because ES 2015 gives us much more syntactic sugar, and it allows us to work on a little higher level. So 20% might not look as much, but the project was pretty interesting because we had a lot of requirement changes, and if you have a lot of, if you have less code on a higher level, it's much easier to work with. And we had a pretty interesting requirement, I don't know, 3 days before production, make it work in IE8. IE10 was predefined version. So, but surprisingly, it wasn't hard. So the only thing we had to do is add a ES5 polyfill for IE8. which isn't ES5 compliant. But that was early 2015, so it's 1.5 years later. The tools got better, they got faster, they got simpler. So let's look at a more modern example. So here's an example here's a project that's actually much older. So the project is 3 or almost 4 years old, but we upgraded it to use Webpack and Babel. And it has a lot of files. So it may have less files than the previous project, but it's much more complicated because it has much more business logic. And it has about 110,000 lines of code when it's compiled, everything together with dependencies. Well, but it's much faster because the full build takes about 30 seconds, which is like 6 times faster. And after every change, it takes about 2 or 3 seconds to update the code, and that's without any manual configuration. So the new tools are taking care of it by themselves. So that's the first part. So this is the standard, the theory. So let's take a look about the real world. So the browsers. So again, 2009. Chrome was at version 3, it was a few months old. We got Internet Explorer 8 and we got Opera 10, which is kind of significant because we got a lot of this. So upgrade your web browser because a lot of pages were using user agent sniffing and a lot of big pages. So this is Hotmail, this is Bank of America. And what they did wrong, they only checked the first digit of the version number, which is really fun. But in the meantime, since 2009, the browsers got better, and they got evergreen. So what's the evergreen browser? Evergreen browsers are the browsers that upgrade by themselves. So the user doesn't have to download anything, click it, upgrade, nothing. The only thing they need to do is click restart the browser, which they do anyway. So this is how the web platform looks today. So we have the evergreen browsers, which are green, and there are a lot of them. We have some browsers that aren't evergreen, but we still need to take care of them. So IE 10, 11, Safari 9, 10. Safari is, by the way, the only one that's still not evergreen. And we have a lot of browser versions that we don't care about, unless you have to work with IE8, which I'm sorry. But the mobile platform looks pretty similar. So Android WebView is evergreen since 2 years ago, since version 5. Android browser is actually the default browser since Ice Cream Sandwich or 4.0 is Chrome, so it's also evergreen. Safari, I guess it's okay because it's getting yearly updates. And even Windows Mobile is evergreen. So Edge in Windows Mobile is evergreen since version 10, since last year. So now it's 2016. How is the support? Well, ES 2015, which you would guess should be supported well, and it is. So most of the browsers, with the exception of IE, support pretty much everything. Even the newer versions, so ES 2016, 2017, are supported pretty well. So ES 2016 has full support in Chrome, and ES 2017 is also going pretty well. So if all our browsers have support for everything now, why are we still developing like it's 2009? Well, because we're transpiling our code and making it work on all browsers because of some browsers that are worse. But when I prepared this talk, I talked about an analogy, how to compare this to some other examples in the real world. And I got one example of this. So this is a book by Randall Monroe. Some of you might know it because he's an author of XKCD. Well, he wrote a book about stuff, so like an encyclopedia. But the thing that's interesting about this book is that he used the 1,000 most common English words to explain everything. So, for example, he didn't use the world's data center because it's not common. He used computer building. He didn't use microwave. Instead, he used food heating radio box. Or he didn't use encyclopedia. He used things explainer. And he even didn't use 1,000. He had to use 10,100 because, well, it's not in the 1,000 most common words. So that's kind of what we are doing with modern browsers now, which I think it doesn't make sense really. So what are the solutions? Well, I have two solutions here. So one can be applied during the development, and another one can be applied in production. So what you can do in development, you can skip the transpilation of code that your development environment supports. So if you're using Chrome or Firefox, they support pretty much everything. So why use the resources and your time to transpile something that they understand? There are some pros, of course, there are pros for it. So it's faster builds. You probably still need to build it, but you don't need to transpile it. So you'll probably only concatenate it or something like that. The bundles are smaller, so it will take shorter time to load them. It will take shorter time to parse them, and the execution will be faster. And well, you might think, well, that's not a real case scenario because my builds in production will be slower, but your development is slower anyway because you have some debugging. You have DevTools open, which slow down your web page anyway. So I think it gives you a pretty real version of your performance. And it's much easier to debug because you don't have those huge stack traces. Of course, there are some downsides because the configuration is more complicated because you have to have a separate configuration for development, separate for production. But since that's a good idea anyway, because well, you have different configs, different ways of deploying your page or app, it might not be a huge issue. The bigger issue is that the transpiled code and native code don't behave the same in every possible scenario. Here it's important to have a staging environment where your code is transpiled and you can test it with every browser and make sure everything works as expected. And also you should run your tests on the full build, so production builds, and of course you have tests, right? Well, the second solution is meant for production, and that's feature detection. So the idea is to check your Google Analytics or some other analytics and group your browsers into a few categories. So evergreen browsers that support pretty much everything, some okay browsers, and some really bad browsers like IE8, I guess. And then you would have separate bundles. For instance, the bundle meant for Chrome wouldn't transpile anything, where on the other hand, the bundle for IE8 would transpile everything, etc. So what you get with this is you optimize for the best case, because most of your visitors are probably using Chrome or Firefox. So why punish them with some code that will be used in 5% of situations? Mm-hmm. And what you get is, again, smaller bundles, so faster loading time, faster parsing time, and less data usage for users. That also might be important in some cases. Again, there's downside. Well, again, more complicated configuration. So in this case, you would have 3, 4, 5 configurations, which it's not meant for every project, but it might be worth sometimes. And again, transpiled code and native code are not the same, so again, the same issue. And in this case, well, all the bundles should be tested, because that's the only way you can, unless you test manually every click on every browser, that's the only way to ensure your page is working in all the cases, in all the browsers, in all versions. And another possible issue is that the JavaScript loading might be delayed because you first need to run your tests what's supported in the browser and only then load your JavaScript. But again, it might be worth in some cases. Well, since this is pretty hard to configure, there's actually one bubble preset that's pretty helpful with it. It's called bubble preset env, and it's kind of an auto-prefixer for JavaScript. And last week when I prepared this presentation, it was in early stage of development, and now it's at point 004, and it's kind of ready to go. And it's really simple to use. So basically, you have your configuration like you normally do, and you just define the targets. So in this case, it would transpile and make sure everything works in Chrome 52. But you could add other browsers and etc. So well, this is about JavaScript. So what about CSS? Well, with CSS we have also a few options. First is using the auto-prefixer. So for people who don't know what auto-prefixer is, it's a plugin that takes your code that you wrote like a normal CSS. You define what browsers you want to support, and it will add vendor prefixes for all the browsers, and it will make sure it behaves the same in all the browsers. The second option is using CSS Next. That's also kind of a transpiler from the next-gen CSS. You could call it CSS4, although this is not an official name. And it would transpile it into CSS3, which you can use today. So what you could get is variables, mixins, and a lot of other stuff that can be transpiled. Again, not everything can be. And the final option is fallbacks. So CSS has its name, cascading style sheets. So you can define multiple values and just let the browser fall back on the value that it supports. And to make this easier, there's actually a feature called Add Supports. It's a CSS and JavaScript API with which you can ask your browsers, do you support this property? And do you support this value with this property? And in that case, you can use one method for those that support or another for those that don't. Well, unfortunately, you can't use add supports to test if the browser supports add supports, but basically only IE doesn't support it. Edge supports it also now. Okay, that's current status of CSS, but in the future we'll get Houdini. So Houdini is a standard that wants to make CSS extendable. So it's very low level, so it allows us to hook into the rendering engine directly and work with it. Well, but since it's low level, it's not meant for app developers. It's more meant for the library developers and people that make polyfills. So this will be really great for polyfills. And what else is great is that it's V3C is working on it, so the standard body. And all the big players like Apple, Microsoft, Google, etc. are working it. So it's really promising. And some of those parts are already in development in Chrome and Firefox, so they can be tried out already. And I think the best sentence for describing Houdini is maybe the most exciting development in CSS you've never heard of. Because, well, it's really hard to find resources about it and find more. But it's getting more known and more details are publicized. So this is about CSS, so let's take a little summary. So for JavaScript, you probably want to use transpilers if you want to use new JavaScript features. If you can, you should avoid transpiling in development, and you could handle all browsers separately, so have a separate build. Well, in CSS, you can use transpiling to use new features, use fallbacks for browsers that don't support new features, and you can't transpile it. And this will get much better in the future, maybe in a year or two already. So this is it from me. These are a few resources you can look at, and thank you.
So if you have any questions, now is the perfect time to ask them. So please, go ahead. Come on, don't be shy.
Yes?
You said Chrome supports all the ES6 features. Does that include imports and exports?
Yeah, so the question is, does Chrome support ES6 exports and imports? So ES6 modules? Well, no. It's currently in active development, but ES6 modules are kind of tricky because theoretically they are part of ES6 on one side, but on the other side they aren't. So ES6 defines the syntax of ES6 modules, but it doesn't define how it will work in the engine. And that's something that they're still working with other vendors and trying to figure out what's the best way to do it. But as I said, it's in active development. I'm subscribed to the bug tracker in Chrome, and there's updates every day now. So it should be really fast. And that's the only feature that's not supported in ES6 in Chrome. Outside of maybe tail call optimizations, but there's also some issues with the standard. Yeah.
Are you at Infinum using some kind of custom builds for the different browsers?
So the question was, are we using? I'm repeating for the mic. So are we using separate builds for different browsers at Infinum? Well, not yet, but I think it's a really interesting idea. I think there are some projects that could benefit from it, but well, not in every case. So there's again a balance, I guess.
When would you use it actually?
I would use it in some performance intense situations. So if you have a lot of animations or you have to do something in real time where the performance is an issue. Also, if you're working with, in some cases, when you have to be sure that the user transfers at the least data possible. So in some countries, the mobile data is really expensive. So if you have a JavaScript of 1 meg, that might be a few dollars in some countries, which is really a lot. Yeah.
What do you do in that case if you have to use it? Like different.
So what would we do if we had to use multiple bundles? Well, we would need to configure our build system. So in case of Webpack, we would probably had to have multiple build tasks or join them in the end. Every one of them would have a different Babel configuration and would output a separate bundle. And then you would probably you would have an HTML file, and you probably could have an inline JavaScript that would check the browser support for some features. Inline because it's not a big, it's not a lot of code, but you save on multiple network requests, and then when you do a detection, you would decide which one would you load. That's kind of the delay that what I was talking about. Okay. Any other questions?
That's it.
Yeah. Thanks.
Thank you.